Hello, guys. Welcome back to Maison African Motives. Still on engineering science N3, working on moments. We have got a question that we are going to focus on from the question paper of August 2015. We are given the first part of the question 2.1, to describe the difference between a point load and a uniformly distributed load. Okay, what is the difference between a point load and a uniformly distributed? So a point load, that is a concentrated load. So what is the difference between these two? Okay, so I want us to check what we have got in this case. And we have got concentrated load is load acting on a point or point load and normally acts vertically downwards. Okay, which is different from the uniformly distributed load in such a way that the uniformly distributed load is a load that is spread evenly over the length of a beam or a part of the length of a beam. All right, so that's the difference between these two. We can illustrate this much better from this part that we have on 2.2, where we are given, in this case, below shows the horizontal beam A, B, C, D with uniform cross-section loaded as shown. So these are the point 30 kilonewton, 100 kilonewton. These are the point loads or the concentrated load. Then the uniformly distributed load is this 15 kilonewton per meter that we see here. That is a uniformly distributed load. So the question is on 2.21 to calculate by taking moments about both supports and test your answer by using Newton's third law, which is the sum of forces up is equal to the sum of forces down. Okay, so that is what you're going to do. So in this case, all right, so let's check it. I'm gonna use this part here. All right, so I'm just going to take it from this part. Okay, so if we are to check here, guys, we have got a distributed load in this case. So let's see the properties of this distributed load. It's distributed from point A up to point C. So that means for these 2 meters and these 5 meters, we are being affected in this case. So it's distributed for 7 meters, okay? So this is going to be 15 kilonewton per meter times the 7 meters, so that we can know the force that is exactly we are using in this case, which is going to be 105. All right, so that was 105 in this case. This is what I got, 105 kilonewton. So that means it is going to be separated between the 7 meters. So 7 meters divided by 2, that is going to be 3.5 meters. So that means 3.5 is actually above these two, greater than 2. So 3.5 we can just expect maybe somewhere here. So that is where I'm going to have it. I'm going to indicate it as a point load as 105 now. So this is going to be 105 separated between the 3.5. So from this point up to this point of C, we are now having 3.5 meters. From this point up to this point here, we are now having 3.5 meters also. That means from this point to this point is actually something like 1.5 if you are to check. 3.5 from this point A to point of 105 kilonewton that we have here. This is actually 3.5. So 3.5 minus 2, which means we are going to remain with the 1.5. So this is going to be 1.5 in between. Then we've got the 5 meters from this point to this point. So that means we are going to remain, this one we said is 3.5 here, so it's fine. 3.5 plus 1.5 must also give us a 5 so that it can make sense also, okay? So everything is fine in this case. Okay, so let's quickly have our calculations. Yeah, everything is fine. So we just want to have our calculations in this case. So let's start by taking moments about C. I'm going to relate to C in this case. Okay, so taking moments about C. We've got taking moments about C in this case, taking moments about C. All right, about C. So about C, we are given in this case at point C, this is our C here. So if you have to check, A is moving this way to C, this is the direction of A. Okay, let me use it another mark, this one. Okay, so A is moving this way. This is the direction of A to C, which is a clockwise direction. So that's a clockwise direction. So that means we are going to relate the sum of the clockwise moments equal to the sum of the anti-clockwise moments. Okay, so A is actually going in the clockwise. Okay, we can see that we can also cross-check the other forces, the movement. Okay, we can check here what is happening with 105. 105 is moving this way back to the point C. Remember, we are relating to point C. So that is anti-clockwise, is moving this way, which is anti-clockwise. So this is going to be anti-clockwise. 30 kilonewton is also at this point B. 30 kilonewton is moving this way back to C, which is also in the anti-clockwise. Okay, let's check what is happening with 100. 100 moving back to C is moving in the clockwise. This is direction. So that's the clockwise. Okay, so on the clockwise, we've got two things here. We've got in this case, the A and the 100 kilonewton at point D. So we're going to combine these two, remembering that force times distance, that is at A, is going to be A times the distance back to C. So this is 2 meters plus 5 meters, which is 7. So that's A times 7 plus, we also have a clockwise. In this case, we said we've got D back to C. It's moving in the clockwise in this case. Okay, so that's 100 by 3. So this is going to be 100 times 3. Okay, equal to, we move on to the ones in the anti-clockwise. We indicated these two, the 105. So 105 back to point C in this case, it has got a difference of 3,5. So you see the advantage of indicating on the diagram. You are just taking your information direct. So this is 105 times 3,5. So that's 105 times 3,5. Plus, we still have another anti-clockwise at B. So this is B back to the point C. So B is actually 30 kilonewtons. So we've got 30 times the distance. What is going to be the distance? That is a 5. B and C, they are separated between 5 meters in this case, if you had to check. Or you can add 3,5 plus 1,5 because this is 1,5. So this is going to give us a 5. All right, so that's it. Guys, let's calculate the value of A from this information. We have got 7 times A, that is 7A, plus 300, 100 times 3, that's 300. Then we combine everything on the right-hand side, which is going to be 517,5. So 7A is equivalent to, if we transpose 300 to the other side of the equation, this is going to be minus a 300. So 517,5 minus 300, which is going to be 217,5. So to find A, divide by 7 both sides. This is going to give us the exact value of A. That is 31,071 in kilonewton. All right, so we have got the point, the force at point A, which is a support. Okay, we can use the moments now about A to calculate for C. So we are just going to, I'm just going to have it this way. So we are going to work with moments this time about taking moments about A. So we are going to take moments about A in this case. Okay, so about A, we are going to see that in this case, depending with your formula, but if you are to check in this case, okay, let me just remove some of these things because we no longer need this part here, and also this one, and also this one, and also this one. Okay, so let's check what is happening here. If we take our moments about A, we are going to see that C moving back to A is going this direction. So C is going to A in the anti-clockwise direction. Remember, if you continue, you're going to have this in the anti-clockwise. So this is going to be anti-clockwise. So that means in this case, you can start with the formula for, since it depends with how you present your formulas, guys. As for me, it's best presenting with unknown value at the start. So I'm going to use this as anti-clockwise moments is equal to the sum of the clockwise moments in this case. So let me check also if I have other anti-clockwise back to A. Okay, so let me see what is happening with the 30 kilonewton here. So 30 back to A is moving this direction, which is a clockwise. So this is a clockwise. Okay, 105 back to A is moving this direction, which is also a clockwise. We move on to D. D is moving this direction back to A, which is also a clockwise. So the rest of these are in the clockwise direction. So we just have only one that is in the anti-clockwise, which is C back to A. So this is going to give us C times the distance of 7 meters, which is 7C, which is equal to, we do not have any other in the anti-clockwise, we only left with the clockwise moments. So we're going to have 30 back to A. There's a distance of 2 here between 30 and A. We have got a distance here of 2 meters. So that's 4 times distance, 30 times 2, plus from the 105, we have got a distance of 2 meters plus 1,5. Remember, from this point to this point, it's 1,5, or just take this one direct, which is 3,5. Already we've got 3,5 there. So that's 105 times 3,5. We also have at point D, plus at point D, there is a 100 kilonewton. So this is 100 sorry, why am I writing the kilo now? So it's 100 times the distance back to the point A. So this is the whole distance, which is 2 plus 3, 2 plus 5, which is 7, plus 3, which is a 10. So it's going to be 100 times 10. All right, so 7C is equivalent to, combine everything on the right-hand side. This is going to give us 1,427,5. So if we divide by 7 both sides to find the value of C, we are going to obtain 203,929 in kilonewton. So to make sure that these values are correct, we are supposed to check to verify. That is what we are given in this case, to verify using the Newton's third law, and which is the one that says the sum of forces up is equal to the sum of forces which are going down in this case. All right, so let's check what we are given on our diagram here. A is going up, so which means if we add in this case A and C, these are the ones which are our supports. So A plus C must be equal to these forces which are going down. Okay, so we're going to add A plus C, which is A is 31,071 plus C, which is 203,929 kilonewton. All right, so this is what we have in this case. So this must be equal to the ones that are going down. So in this case, we can just indicate that the sum of upward forces is equal to the sum of the downward forces. Okay, so we can check here, which means now we are relating to 30, 105. It's now a point load. We are relating as a point load of 105 and the 100. This 15 kilonewton per meter is the one that gave us 105. So we just relate to these three: 30 plus 105 plus 100. So this is going to be 30 plus 105 plus 100 in this case. All right, so this is going to give us 235 kilonewton, which is the same as this side, 235 kilonewton, which means our values are very, very correct. All right, so that is how you can actually prove to see if your answers are actually the same. So if you've taken your moments from different conditions and this is actually giving you the exact answer, it means you're actually in the right direction. But don't calculate one value, then you use this information, then you prove again from this, which means you are misleading yourself. Do the exact thing from the taking moments about each point separately. All right, so that's what we had from this part. we are going to move on to the other part of the question. Let's check what we are given. And now we are given draw a shear force diagram. In this case, okay. Using a suitable scale, okay, show all the main values on the diagram. So I'm just going to show you the main values because in this case, guys, the issue of suitable scale is going to affect me. Okay, so remember the values of A and the values of B because I just want to remove this part. It's not going to affect as much, so I'm just going to remove. I want to work it from this diagram here. Okay, so now we want to have our shear force diagram from this point or from this one. Okay, so we are going to have this is 2.22. Okay, so what I'm going to do, let me just extend this diagram. All right, I'm just going to need a ruler in this case. All right, so let me just take my time so that you can properly see, guys, what I'm trying to do in this case. All right, so I'm just going to extend our major points. All right, so we've got a major point at A. You understand this, guys, much if I'm giving it this, if I'm using this way. We also have a major point at B. All right, so like at B here, I'm going to extend this one. Also at C, okay, at point C, we have got a major point there. Okay, sorry for this. Then also at point D, we have a point D in this case. All right. So now, guys, we have to relate these points very, very much. These are the major points that we have. And if you relate from these points, you won't even go wrong. All right. So this is what we are going to do in this case. Okay. I just want to go back to 0 again. Let's get back here. All right, like this. All right, so let's just hope, guys, this is not gonna affect us much of our time. All right, so I'm just going to take it this way at this point. At this point is even fine. All right, so this will be our horizontal axis where we are taking our values from. All right, so let's relate now to the information that we are given, guys. The first part, we can see that from the point A, we have the value of A. Remember that our A was 31. So let me just write 31, 071 kilonewton. Also, the point C, we found this one. It was 203,929 kilonewton. So this is what we're given. So at this point, A, it's a support, it's going up. So A is actually at the beginning of the diagram here, it's actually going up. So we actually supposed to be at 0 at this point, at 0 kilonewton. But direct at this point, A is going up. So which means we are just going to add this A to 0, that's 0 plus 31,071, which means we are going to remain at 31,071 because it's a support, it's going up. A support goes up like this. So you add and you are just going to draw a vertical line direct. So now when they are saying use a suitable scale, they are saying at this point, you must have a suitable scale that you're going to be using. So in this case, unfortunately, here I do not have a suitable scale that I'm going to use. I'm just going to show you the major points which are very, very important. So you're going to be at this point, let's say, assuming this is where we have our point 31.0 at this point here. This is going to be 31.071 kilonewton at this point. Okay, I want us to see, guys, if you have this from the diagram, you understand better. If you have to check, you're going to move from A to B. But moving from A to B, there is a distributed load of 15 kilonewton per meter, which is affecting from A to B for these 2 meters. So meaning to say, we are going to subtract a point load. We know that this is going to be a diagonal line like this one, okay? But we subtract because it's on top, it will be facing down. So at 31.071, we are going to subtract the 15 kilonewton per meter, but multiplied by 2 meters. It's affecting for these 2 meters from A to B. So this is going to be 15 times 2 like this. Okay, so if we subtract this part here properly, we are going to have 1,071 kilonewton. That is where we are now. So 1,071, just approximating your values, directed point B, it can be somewhere at this point. So I'm just gonna assume somewhere at this point here. So this is a distributed load. So if you join it, it is going to give you a diagonal line of this nature here. Okay, so you're going to join from this point up to this point. All right, something of this nature like this. All right, so this is where we are now at point B, which is, we said this is at 1,071. All right, so let me just write this 1,071 kilonewton. All right, so this is our major point. Then at B, direct at this point B, we are given a point load of 30 kilonewton, which is going down. So we are going to subtract this point load 30 kilonewton. All right, so at 101, comma, this value that we have, 1,071, we are going to subtract the point load that is facing down. So a point load faces down direct, so you subtract that one, 30 kilonewton. Okay, so if you subtract 1,071 minus 30, we are going to obtain negative 28.929 in kilonewton. So this is going to be negative. It's a point load, it goes down straight. This one, it goes straight down. Okay, so from this point, we are going to straight up to negative. So let's say approximately we're at this point. So which means we are going to join this straight. This one, you join it straight, guys. Do not confuse this part. Okay, so you join it straight like that. Okay, so this is at negative 29. So that is negative 29 comma. Okay, yeah, I was supposed to use another pen so that you can actually see it properly. Kilonewton like this. So this is where we are at this point. Okay, then if you are to check here, from the point B up to point C, it's a distributed load again, 15 kilonewton per meter for 5 meters. So we're going to do the same thing what we did from A to B, which means we are going to subtract 15 times 5 this time. All right, so this is going to be at negative 28.929 minus the 15 kilonewton per meter times the distance that is being affected for this portion, which is 5. This is going to be at negative 103.929 kilonewton. So that is what you're going to have. Remember, this is a distributed load, so it's going to be a slanted line like this. So at negative 10, that is this point. Maybe we just assume maybe at this point here, that's where we have our negative 103.929 kilonewton. So you join just like previously. So we're going to join these 2 points. All right, so here's just a matter of joining the 2 points, this one and this one here. Okay, so let's join from this point up to this point. That's how you indicate your distributed load in this case. All right, so let's check what happened again from the point C. At point C, we have got a special point which is there, which is a support of 203.929. So a support, it goes up, we are going to add. So we are going to add at this point at negative 109 point this, we are going to add 203 point this, which is going to give us 100 kilonewton. So if you add properly, you are going to obtain 100 kilonewton in this case. Okay, so the 100 kilonewton is direct up. So you're going to mark this point. Okay, yeah, guys, I think everything is clear. So you're going to mark this point at 100. just an assumption. Let's say we are at this point here, 100 kilonewton. Then from there, from this point to this point, there's a distance. So this one, you just move a distance, okay, straight to point D. Here we just maintain 100 straight at point D. So we are at 100 kilonewton at this point. Then from there,